Stop. My mouse isn't working very fast. I'm sorry that you're listening to me complain about this. So we are going to do 3-3, which is about sum and difference identities for cosine. Okay, so I'll write sum. And so the first thing I'm going to do is an example of what not to do. So make sure I'll use a calculator to do that. Then with the calculator, so when I have to do the sum or a difference, so what it's going to look like, a big what not to do, so not this, is if I have the cosine of two angles that I'm just going to say alpha and beta, so Jesus fish plus fancy bee. Okay, so the sum of alpha and beta is not equal to cosine of alpha plus cosine of beta. So do not do this for anything. Okay, so just an example that this does not work is we are going to do, on this left-hand side, we're going to work with cosine of 30 plus 45, right? So what we really should be finding is cosine of 75, because we should do our parentheses first. Okay, so let's make sure I'm in degree mode, because I was really talking about a lot of degrees there. Okay, so if I asked for the cosine of 75 degrees, you get 2588. 0.2588. Okay, that's fine, but I just want to show you, so if I did the cosine of 30, that would be 0.866 right here, plus the cosine of 45 would be 0.707, and then if I added those two things together, that is not equal to the 2588. So I would get 1.57, which is not right. Okay, so that's a big example of what not to do. Okay, so make sure you add the angles. And so what we're going to have is, it's not always nice numbers that we can just plug in. So we want the exact values a lot of times. So what happens with those exact values is that I want giant square roots. And sometimes the square roots look pretty gross. But I just wanted to show you real fast that this is not true. So what we will be doing is using a lot of the unit circle. So do you guys all have that and find your unit circle? Okay, so your cosine rule for when I have the cosine of two angles added together will be the following. So just kind of keep it handy, and it's a little bit like, this is the right thing to do. So this is a big don't do this one. Okay, so it is going to be the cosine of the alpha one times the cosine of the beta one. I guess I didn't really need parentheses. Minus the sine of the alpha times the sine of beta. So I could have put parentheses around there, but okay, I just did. Okay, so that's what we're really going to do. So the problems that you're going to be given with this guy are, they're like, I don't know, the easy stuff is actually kind of finding them on the unit circle. So do you remember it's cosine, x or y? X and sine is your y values for each of these things. Okay, so we're going to use both of them in different places. We just have to remember those. Okay, so if I asked you to find the cosine of 75, I don't actually want this decimal that was 2588. Okay, I know that's what I should be getting at the end for my simplified thing. So if I asked you to do the cosine of 75, okay, the process that you're kind of going through is, okay, how can I get to 75 using all these degrees that I actually know about on here? Okay, so hopefully you'd come to 30 and 45. Okay, so then I'm going to do cosine of 75 equals cosine of 30 plus 45. And it wouldn't matter which one you did in which order there, right? Okay, so I'm going to then use the cosine of alpha, so I'm just making sure that I say 30 is my alpha, 45 is my beta. Okay, so I'm going to start with cosine of 30, so I'll need the cosines of each of them. Okay, so I'm going to write it out. You guys probably would not be writing out this first line, okay? So I would write cosine 30 times cosine 45 minus sine 30, sine 45. Okay, so then cosine 30, so we said cosine are x values. So cosine of 30 is square root of 3 over 2. Times the cosine of 45. The cosine of 45, so I go find my 45 degrees. My x value there is square root of 2 over 2. Minus, then I'm going to need the sine of 30. So come back here to 30. 30 is a y, sine is a y. So minus sine of 30 is 1/2. Sine 45, come up here, use my y value, square root of 2 over 2. Now what I'm trying to mostly do, that's probably the easier part, is finding your values. Just keep track of cosines are x, sines are y. So now what I want is to remember all your square root multiplication things. So on top here, I have the square root of 6 over 2 times 2 on the bottom is 4. Minus on top here, I have 1 square root of 2 over 4. I want to write this as a single fraction. So what your answer, so this would probably, like if you were typing this in, this would get you the same decimal. But what I really want is like a giant thing over the same denominator. These same denominators happen to be 4 here, so that's good. They're not always going to be the same, so you might have to get a common denominator. But then you'll just have the square root of 6 minus 1 square root of 2. You don't have to write the 1, but just make sure you keep track of whatever numbers you would have in front. Okay, so that's the amount of work that you would be doing with that. I want you to go through and quickly check that with the calculator just to check your answer. So you should be able to type in parentheses, the square root of 6 minus the square root of 2 all over 4, and I should get that 2588 that we already figured out. Okay, just from that other example. I just don't want it as a decimal. I want the long, gross version that for some reason mathematicians have always thought looked nicer.
Whose bottle is this?
Okay, so that was the cosine for a sum, all right? So this was a sum. So now we're going to do the cosine of a difference identity. So I don't need this page in here. Okay, so I'm going to have a cosine of alpha minus beta. So this one, the order does matter because alpha definitely has to be the bigger one. Okay, so my equation for that guy is going to be cosine alpha times cosine beta plus sine alpha sine beta. Make sure, please try to memorize these things because I think tomorrow we're doing sine and tangent. Okay, so it does kind of make sure that you're using the right one. Okay. Okay, so let me do this one with a subtraction because it actually has some radians instead, and we haven't had to do some radians for a while. Okay, so if I ask you to do the cosine of pi over 12, okay, how am I going to get that with subtraction? Okay, so think about it as 1/12. So you need to kind of just play with lots of things. So what it's actually going to be is the cosine of pi over 3 minus pi over 4. Okay, so if I did cosine of pi over 3, remember that that is 4 pi over 12 minus 3 pi over 12, and that ends up with this 1 pi over 12. Okay, so you'll have to do some of that with some crazy fractions in there, and that's, I think, the worst part is finding out what those fraction-y dudes are. Okay, so then I'm going to use my dude, and we don't have a pi over 12 on ours. So we will get a chart, or no, we don't need a pi over 12 because we're going to use the pi over 3 and pi over 4, which was the entire point of doing this, okay? Is that we haven't come up with the pi over 12 identities or anything like that. Okay, so I'm going to have the cosine of my alpha. My alpha is pi over 3. Cosine is, so pi over 3 is 60 degrees, cosine 1/2. So I'm going to have 1/2 times the cosine of beta. My beta was pi over 4. Cosine is x, square root of 2 over 2. Minus the sine of alpha. So sine of alpha is pi over 3 plus, thank you. So I have pi over 3, sine is square root of 3 over 2. Sine of beta, beta is pi over 4, square root of 2 over 2. Do the multiplications. A lot of these things are going to look really, really similar, right? Because they're already looking similar. So I have the square root of 2 over 4 plus the square root of 6 over 4. So you'll have the square root of 2 plus the square root of 6 all over 4. Okay, so that's what your final answer looks like. Again, like, I don't know. I think trying to find some of those weird numbers, or like if you wanted to convert it to degrees first, that would maybe be a little bit nicer. And then you could use the degrees version of it. It might be easier to see. Okay. It's just a few things to write down, but they're not crazy gross. Okay, so some of the things ask for sine and cosine to rewrite things using sine or cosine. So if I said the sine of pi over 2 minus u, where u would be like an angle, I need to write a u. That's a u. Is equal to cosine u. Okay, what is pi over 2 equal to, you guys?
360, 180.
90. Okay, so this is the same as saying 90 minus u. Okay, for all these things. Okay, so again, the opposite of that one would be that cosine of pi over 2 minus u is going to equal the sine of that u, whatever that u would happen to be. So you can go back and forth with some of these guys, okay? And that you would have to do a little bit less work. Okay, tangent and cotangent go together, so I'm going to write them small now. And remember, if you needed to, you can convert any of these to 90 degrees instead of pi over 2 with radians. Cotangent of pi over 2, that's a pi over 2 minus u is equal to tangent of u. And then secant and cosecant go together. Secant of pi over 2. And they all say pretty much exactly the same thing in here. Pi over 2 minus u is equal to now cosecant of u. So cosecant of pi over 2 minus u is equal to secant of u. Okay, so pretty much all that means, if I gave you things in degrees, if I said sine of, let me find one, of 20, you should just subtract that from 90, that number, and that's going to equal that cosine. So cosine of 70. So those two things I know are equal based off all these things.
So you just take 20 minus 90?
Yeah, so then if you did, yeah, that's pretty much as bad as they get, and I think they're all in, there's a couple in radians, but you would just do pi over 2. So if I did, as another example, so if I did secant of pi over 6, which one would go with that? So you would do pi over 2. Whoops, I keep minus pi over 6, because pi over 2 is another way to write 90, right? How about I write the same thing? That's a 6 now. And this one's a 2, because I can't write anything. Okay, so I need a common denominator, so times 3 times 3. So I'd have 3 pi over 6 minus pi over 6. And I would have 2 pi over 6, which is pi over 3. And then I would write secant goes with cosecant, so I'd write CSC of pi over 3 is what it's equal to. I just didn't really get a good equal sign. Okay? So those are kind of that last little bit that they're just trying to throw in there because it needs to go somewhere. So I want you to do 5 through 42 by 3s.
How do you do 5 through 40?
I don't know. How about 6 through 42? Don't judge my math skills. And then I want you...
Please tell me that's on recording.
Yeah, no, it was. 43 through 58.
Are you going to get your gotcha later?
Those are matching, so, and they're pretty easy matching too. And then 60 through 63, 6 by 3s. What do you want me to write? You want me to do just 60, 63, 66?